Okay, in this video, we're going to continue our discussion about significant figures. So we learned how to count significant figures for any measurement because we want to show certain level of accuracy of the measurement. So sometimes we have to keep certain number of digits before and after the decimal point. So how is that going to affect our calculations? So here's what we're going to learn about significant figures in mathematical operations. So basically, there are four types of calculations. Multiplication and the division. So we're gonna put them into two categories. For multiplication or division, we're gonna keep the number of significant figures in the answer as the same as the one in the measurement with the smallest number of figures. What that means is when you are doing multiplication or division only, okay? Now you're gonna have, in this case example, you have a number with 1.342 which has 4 number of sig figs, and 5.5 has 2 number of sig figs. Okay, so when you multiply this number, when you type them into your calculator, obviously you're gonna have some pretty long number here. Okay, but you have to keep in mind you start with a number with 4 sig figs, and this number has 2 sig figs, and your result has to go with the lower number of sig figs out of these two numbers. So your answer is supposed to only have 2 sig figs. Obviously, you're going to keep the 7.3. So here's where you need to do a little bit rounding. Okay. Now, when you're in this case, when you are trying to keep 2 sig figs, which is 7 and 3, you're dropping 8, so you need to round up to 4. So the answer is going to be 7.4, which basically is showing you that your calculated result is not supposed to be more accurate than the number you've used in the calculation. Okay, let's look at another example here. 66.543 times 14.6 divided by 3.634. So you can see you have three numbers. You have multiplication, division. Okay, so you're counting the significant figures of each number. This one has 5. 14.6 has 3. 3.634, that's 4. So once you got the answer, the raw number from your calculator, you can see this is a fairly long number, okay? But this number result is supposed to go with the lowest number of sig figs out of three numbers, which is 3. So you're going to keep 267, drop the 3. Okay, here when you're dropping the 3, that's lower than 5, so you're going to just round them off, keep 267. Okay, it's 3 sig figs. Now, you're probably notice that even though you have all of those decimal places of all three numbers, but we're not looking at decimal places, we're counting significant figures for multiplication or division. Now for addition and subtraction is going to look different. Okay, the limited term here is not the number of sig figs anymore, it's the smallest number of decimal places. Okay, so when you're doing only addition or subtraction, you're not counting sig figs, you're counting decimals. For example, 140.0 plus 128.75. Okay, so this is an addition. You have two numbers, you're adding them up, and then the answer you can put into calculator will give you 268.75. Now the way you round this number down is you're counting decimals. 1 decimal, 2 decimal places. So your answer is supposed to go with the lower number of decimal places, which is 1. So you're dropping 5. Okay, this will be rounded up to 26. Oh, excuse me. It's going to be 268.8. Okay. Now when you doing a subtraction, it's going to be exactly the same way. So for instance, 120, it's a whole number, minus 17.25 equals to, if you put them both into a calculator, it's going to give you 102.75. Okay. Now when you look back to these two numbers, okay, you need to count decimals. 120 is a whole number, so the number of decimal places here is 0. 17.25 has 2 decimals. So your answer should have, between 0 and 2, should have no decimal places. That means the 75 should be gone after decimal point. And since you are dropping a 7, this 2 needs to be rounded up to 103. Okay, that's the difference between subtraction and addition from the multiplication and division. Okay. Now there's one more thing we need to learn here before we move on to more complicated calculations here. Okay. So is that going to be the case that we have to count sig figs or decimals all the time with all of the numbers? Not really. There's some numbers you don't really have to count either significant figures or decimals, which are called exact numbers. Now don't confuse this with the whole number. Okay, exact numbers, they don't have the whole numbers. So exact numbers are supposed to have infinity number of sig figs. They have more than anybody else. Okay, they have more sig figs than anybody else. And these numbers are usually to be two kind of numbers, either counting numbers or artificially defined numbers. What does that mean? Well, let's say 1 inch is 2.54 centimeter. That's a defined conversion factor. So there's no uncertainty of this either 1 inch or 2.54 centimeter. In other words, if you put the 1.0 inch equals 2.54 centimeter, that does not make this 1.0 more accurate than the 1. So that's what we mean by 1 inch is an exact number as well as this 2.54. Anyway, any conversion factors are exact numbers. Another one example will be here. 1 meter is 100 centimeter. So this 100 centimeter, even though it looks like there's only one sig fig, but it actually has infinite number of sig figs. That's defined by centi. Okay, 100 centi is 1. So that's the exact definition. Another kind of numbers, they are always exact numbers, are counting a number. Okay, such as if you have 9 pencils, okay, that means 9 pencils. So there's no difference between 9.0 and 9 pencils. Okay, or if you do a head count in the classroom, counting how many students, okay, that's always going to be a whole number, which is also an exact number. Counting the number is always accurate. Okay, so they don't have, they don't need any number of sig figs, or you can always say they have infinite number of sig figs, simply because they are more accurate than any other numbers. Okay, so also the other way you can remember this is any measured number. Okay. Any measured number, you need to take sig figs. Any number calculated from measured numbers, you need to count the sig figs. Okay. Let's take a look at one more type of calculations here, which is basically combined multiplication and division. Okay. If you have a series of calculations, it means it's more than a step. Okay. What do? If we have mixed up multiplication or division with subtraction or addition, what do we do with the intermediate numbers? Well, the rule is simple. You need to carry all the digits to the final step. You don't really do rounding. Okay, you just basically carry all of the digits that show on your calculator until you arrive at the final number, the final answer, and then do the rounding. You only do one rounding. Okay, so let's take a look at the example here. Now, there's a 140 minus 70.1. Excuse me. Parentheses, and then this result will multiply by 12.5. So this is a calculation. You have to do what's in the parentheses first, and then do the multiplication. Okay. If you put this thing in the calculator, you will find what's in the parentheses here. The subtraction will give you 69.9, again multiplied by 12.5, and then this multiplication will give you a number like 873.75. Now the question is, how do we count either decimal or number of sig figs here? Well, we just need to go through step by step. Okay, step 1 is the subtraction. Okay, presumably we're supposed to count the number of decimals when we're doing the subtraction. 140 is a whole number, so it has 0 number of decimal. 70.1, it has 1 decimal. So in other words, the result coming from the subtraction is 69.9, which is supposed to have 0 decimals. But keep in mind, we don't do rounding here. We keep all three digits here, 69.9. But at the meantime, okay, this could be a little bit confusing. At the meantime, you have to keep reminding yourself this number is supposed not to have any decimals. In other words, this 0.9 should not be there. It should have been round down or round up to 70. In other words, the number of significant figures here is only 2. Okay, the reason is this number is not supposed to have any decimal. This 9 should not be there. But we kept it there for the sake of accuracy of the calculation. You see, you need to carry all of the digits that's shown on your calculator until your final step. So we kept this 9 here, not because it's significant, it's because we want to keep it accurate. So this 69.9, you can imagine this number has only 2 sig figs. Okay, you need to carry this information to the next step because we can see that next step we're doing multiplication. And we will have to count sig figs for both numbers. So 12.5 is obvious, it has 3 sig figs. But 69.9, because of the last 9, second 9 here, it shouldn't be there. So this number has only 2 sig figs. But even though it shouldn't be there, we don't really do rounding here. Okay, so you're looking at 2 sig figs versus 3 sig figs. So your final answer should only have 2 sig figs. In other words, this answer should be round up to, or round down to A70. 870. You're dropping the 3, okay, but you can't just drop the 3 and change it to 87. You have to make sure the 870 stay at their own digits. Okay. Alright, so that's another, here's another example. Excuse me. You can try to pause it here to see if you can find out the answer of this calculation with correct number of decimal sig figs after rounding. Okay, if you come back from your calculation, you will see you're still supposed to do what's in the parentheses here. So you copy down this 1.25 times. What's coming out from this parenthesis subtraction is 0.75. So you're supposed to count the significant figures here. 1.25 has 3 multiplication. Now this 0.75, how many sig figs does it have? Well, is it 2? No. Well, this 0.75 was calculated from 2.0 minus 1.25, which is a subtraction, in which you're supposed to count number of decimals. Okay, when you count decimals, you will see there's 1 decimal here, there are 2 decimal here, which means the result of this subtraction, which is 0.75, should only have 1 decimal. In other words, this 5 could have been dropped or rounded off, but we didn't, because this 0.75 is not final answer. It's just an intermediate. We need to keep all the digits, but at the meantime, you need to remember that 5 is not a valid digit there. Okay, you need to keep in the calculation, but when you count the sig figs of the 0.75, you should only count 0.7, which has 1 sig figs. Of course, 1.25 has 3 sig figs. So the answer coming out from the calculator of this multiplication is 0.9375. Okay, now if you look back to these two numbers, 1.25 has 3 sig figs, 0.75, because of that 5 should have been dropped, which we didn't. Okay, so it only had 1 decimal. So this number can be rounded down to 1 decimal. 0 is not significant. Okay, so you need to round down to, I'm sorry, 1 sig figs. 9 is significant, so you need to drop the rest of digits. 0.9 with only 1 sig figs. Okay, all right. So here, this is how you include the significant figures in mathematical operations.